Okay, we've got an exciting one today. This is a video on root cause analysis with Motif. We're working with the Motiflix dataset, which are the kind of events you'd see with a video streaming service. We've tried to make these guides things that you're likely to need to do with your job. Root cause analysis is one of those things that you're probably not planning to do, but you end up having to do. So I hope you watch this video because it brings together a lot of the things that we've learned so far and really gets to this kind of exploratory aspect of what Motif can do and really breaking down a problem very quickly. So I think it shows off some of our capabilities really well. All right, so imagine someone came to you and said, we've seen a decline in watch start events and we're trying to understand what happened. So watch start is the key event for our video streaming service. So this is really important to our business that we don't see this big drop. So right now in kind of a blank new workbook, we have sequences that are at the user level. But we probably want a unit of analysis that's a little finer than that. So we're going to sessionize the data. We're going to use Copilot like we have been, and it generates the sessionization code. We've been using 1 hour sessions, so we're going to continue that. I talk about this more in the duration and sessionization video if you have questions about how that works. And most sessions begin with homepage. Some begin with sign up, followed by homepage. So we're just going to align everyone on that homepage event. We're going to follow that by anything and follow that by watch start. So this is going to include almost every person since everyone starts on the homepage, or every session. Everyone starts on the homepage, and a question mark for watch start means it's optional. So this will include every person whether or not they get to watch start. So I'm going to go to a plot. And when we're plotting over time, our x-axis is usually going to be this sequence start timestamp. And so our sequence begins with home page, and so the timestamp of that home page event is what this will basically mean. So we'll pick that. We're going to bin this by date, and so now we're plotting sequences over time, aligning on that home page event. I'm going to use align, and we can see our product has grown over time. And so naturally we're starting more sequences that way. Now for the y-axis, we don't want to count. We want to know whether or not someone got to watch start. And I talk about this in the conversion rate video, that this exists feature for one of the tagged events is a great way to get your conversion rate. So if I hit that, it's basically a 1 or 0 whether the user watched it. So we plotted a bunch of 1s and 0s here, but we need to aggregate that. So now we're going to take an average of that within the date. And so now for every day, we're going to see the percentage of people that made it to watch start. So it looks like in the beginning, it was less stable when we were smaller, but hovered around this kind of 65% to 70%. As we got bigger, it stabilized, meaning it didn't go up and down quite as much. And then something happened around May 5th or so, May 3rd, where we saw this step change. So maybe we did a great product improvement there, and we got to higher conversion to watch start. But then here's the issue that we're talking about today. And starting on June 24th, we really saw this drop in behavior of getting to watch start. And so this is the issue we want to investigate. Before I zoom into this problem time period, I really want to understand what changed. So I need a little bit of data before the problem and, of course, the data after the problem. So the first thing I'm going to do is limit the data to events after June 1st. And that's going to give me a nice window kind of before and after. So remove events before June 1. So again, I'm using our Copilot just so I don't have to remember that. Sol. What it's doing is within every sequence, it's finding the first event, or it's matching the first event it finds, because this is just a wild card, basically, any event. But the if statement says the timestamp has to be greater than, we want 2024, so June 1st, 2024. So it's going to kind of go through the sequence until it finds one that's greater than June 1st, greater than or equal to June 1st, 2024. And then once it gets there, it's going to replace the whole sequence with the matched portion, which is that first event, plus the suffix, everything after it. So this basically is just trimming off everything ahead of the first event that it finds that's greater than or equal to June 24th. So that's exactly what we want. I'm going to hit run query, and we should see it, disappear before June 1st. So here we are, June 1st, and then we hit June 23rd, and then the first drop is on June 24th, and so on. Okay, so we've given ourselves a nice time period to investigate. Let's start to compare what was going on after that time period and before that time period. So for this, I really need some anchor to compare these things. So I want to create a flag, basically, that shows me if I'm in the problem area or not in the problem area. Okay, we click back over to examples, and now we're going to ask our Copilot to add the flag on events after June 24th. So I'm going to say for each event, if it occurred after June 24, add a flag that's true, otherwise false. Let's see how that works in my kind of plain English. Okay, so what it did was a match split on event. This basically, because the parentheses are empty, we're matching any event, and there's no plus or star, we just match the first event we find. We split, and so this effectively takes every sequence and breaks it up into single events. And then it looks at that and it says set this flag based on this if statement. I'm going to rename this flag in problem area just so it's easier to understand. And I'm actually going to get rid of this if statement because we can just do that right here. So if the event timestamp is greater than 6/24/2024, this is going to be true. So in problem area is going to be true. If the timestamp is less than that, it'll be false. I'm going to make this greater than or equal to because I'm pretty sure the 24th was our problem area. And then combine, we're going to stitch all those sequences back together. So this is basically breaks everything into single events, does an if statement, assigns the flag, and then stitches them all back together. All right, we're going to click over to plot and just take a look at what we did and check that it worked. So I'm going to go to home page and then in problem area. Now we're plotting that, still plotting that over time. We're still looking at count star. We're still looking at our home page to watch start. And we see it goes from true, and then on the 24th, it goes from false in blue and flips to true on the 24th. Great. Another way to look at this is with dimensions. So dimensions is going to be a way to look at the data in aggregate on your tagged events. So we see iOS, Chrome, categories null. In problem area, this is the flag we made. It's mostly false and then true sometimes. So that doesn't tell us that the cutoff worked at the right time. We had to plot it over time to get that. So now we have a flag that denotes the problem area and the non-problem area, and we want to compare those. Barcode is a great way to do that. I'll start on the tags. And tags is just going to highlight the things that are in my last match. This is sort of the match I'm using for analysis. And home page is in blue, watch starts in red. You can see most sessions begin on home page. And so that's this big blue, and then they end up in watch start a number of different ways. Through search, through favorites, through homepage click, through top movies page, and on down. So we actually want to compare. So we're going to go to compare. And the dimension we're going to use for comparison is this new flag that we created in problem area. So there's going to be two groups, true and false. And false is in blue. So if you're not in the problem area, you're blue. And if a path is more common for the people that were before the problem area, it's going to be more blue. If it's in the problem area, it's going to be more orange. So right away, we see this big block of orange that means that people in the problem area were more likely to use the search page. And we see the difference is 2.1%. Down here we see some blue, and so that means people that were not in the problem area were more likely to visit the top movies page. And it's negative 1.1% toward the problem area, so that means greater for the non-problem area. We'll look at a couple of other these. Search clicks is up, that makes sense. Favorites page click is down 73.3% for people in the problem area. So it's blue because it's more common. A click is more common if you're outside the problem area, much less common if you're in the problem area. So something clearly went wrong here. We went from, some number of favorites clicks, 110,000 before the problem area to 0 after the problem area. So something went wrong with those favorites page clicks. So let's take a look at what happened after people went to the favorites page. So I'm going to comment out that analysis, and I'm going to do another one on favorites page. So this will match everyone who went to the favorites page. And I want to follow that by whatever page they went to. I'm just going to call it destination. And that'll match anything. So whatever page people went to. If I go to examples, we'll see favorites page followed by destination. And it's favorites page click for this person, but home page for that person, and so on. I could do a match split here if I want to see if someone did this multiple times in a session. So I'll go ahead and do the match split, and then on the off chance that, like this person, they went to it twice, we can see in aggregate how that looked. All right, so let's plot that. So we've got the sequence start timestamp, which is great. We've got the count star, which is great. We want to look at the page they went to. So that's going to be destination, and then we have something on destination called name, dimension, that we can plot. Now we're going to group by that, so we'll see these count stars over time. So here's the most common thing people do after the favorites page, which is they click, and then that turns into 0, just like we saw in the barcode. And then we see this in orange, the home page goes up slightly, and then search goes up slightly, which we also saw in the barcode. So we kind of saw this in the barcode, but now we can really see it over time, and we can see that moment where it just craters to 0. So what happened to the favorites page just then? Well, on the favorites page, we have a dimension that's called the movies number. And so this is the number of movies that someone saw on that page. Maybe they have 0 because they didn't have any favorites, but normally this number is greater than 1. I'm just going to group by it. It's a little messy right now because we have every single value, but we can see that there's all these different numbers that people have of favorites, and then they all go to 0. And then the 0 favorites, which, some number of people have 0 just because they haven't added any favorites, but that shoots up, and then all of a sudden it's the only value that anyone has is 0. So this feels like a bug where all of your favorites disappeared, because we used to see multiple favorites on the screen, and now everyone sees 0 favorites on the screen. So we think we got to the answer here. Another way to look at it would be dimensions. So if I go to dimensions, I should be able to see that movies number, and here it is, overall, there's a lot of 0s. I can go to my query and filter down to anything after the 24th, and then go back to dimensions, and I'll see that same dimension number in problem area is true, of course, because now we're only in the problem area, and movies number is in the 0 to 1 bin. All of the data is in the 0 to 1 bin. So this dropped from a nice distribution to basically 0. So we think we found it. That's great. So we did a lot here. The first thing we did was basically do a vanilla match after sessionization to see the drop in the data. And then we narrowed down to an analysis range starting in June 1st around the problem area. And then we created this flag on every event, whether it was in the problem area or not. That allowed us to use the barcode and compare things inside and outside the problem area. And finally, we saw this drop to favorites page, which we analyzed in both the plot, and then we also looked at the dimensions for that. So we found the problem. Let's go tell our engineering team, our engineering partners, that we think we have an idea of what went wrong. So I hope that helps.